put yourselves in a position for a boundless catastrophe of remarkable extent underneath the purple Goliath. CB changed on the edge of our structures, passing on inauspicious messages through the universe utilizing the James Webb Space Telescope. Cosmologists have decided something fundamentally agitating about this critical, huge body, as astrophysicist Brian Cox offers a grave affirmation: the inquiry weaving machines. We say we are on the incline of seeing an unfortunate, pretentious impact that may forever change the night sky to the degree that we can be involved. We ought to jump into the surprising woven work of art of the universe, where stars are thought about, live and die in wonderful plans. One superstar has truly gotten the imagination and kind of cosmologists and the public the same. This notable star is a red giant of huge extent and age, coordinated obviously inside the great body. Its irrefutable tan variety and intricacy have for a really long time been a wellspring of interest. Later, enhancements enjoy sustained leisure activity in this amazing monster, as we find the plausibility of an approaching brilliant event in the current occasion of this star. Paying little mind to what these activities may infer, we may be on the cusp of seeing an interminable showcase of improbable scale over our child. It is a wonderful behemoth. Its full, huge size is almost beyond human ability to get a handle on. Imagine a star so huge that if it were to dislodge our Sun, its surface would reach out past the circle of Mars, overwhelming Mercury, Venus, Earth, and Mars in its heavenly hug. This isn't simply a remarkable showcase of the star's genuine characteristics, but also represents its stage in the brilliant life cycle. As a red giant, it is in the twilight of its presence, a phase described by development and cooling following a lifetime spent consolidating hydrogen into helium in its center. Anyway, what might be said about the age of this megastar? Estimated to be around 8.8 to 8.5 million years old, it is relatively young in human terms, but old concerning heavenly lifetimes. It is in the red giant stage, a consequence of millions of long stretches of heavenly advancement, marked by significant changes and cycles that have transformed it from a hot blue star to the red giant we see today. The current example of stars like this one is a story of development driven by the consistent forces of atomic combination and gravity. Its sketchy rosy color is another sign of its constant stage. The red tone is a consequence of its somewhat cooler surface temperature compared to different stars like our Sun. While the Sun's surface temperature is around 5,500 K, this star's cooler surface registers temperatures around 3,500 K. This cooler temperature gives the star a red appearance, but this tone isn't simply a visual element, it provides scraps of data about the star's condition. Also, the cycle occurring inside it adds to the star's character. Another fascinating aspect is its variable nature. Old Roman and Chinese works suggested that about 1,000 years ago, it became yellow. It was in the 9th century that Arabic astronomers first described it as red. This variety shift over human history isn't just a detail in the annals of cosmology, but a sign of the star's enormous changes. The variable brilliance of the star is another captivating aspect. It is a semi-regular variable star, meaning its light occasionally fluctuates. This inconstancy is an infinite dance of brilliance that has charmed stargazers and skywatchers for hundreds of years. Ordinarily, the star undergoes a multi-day cycle, along with a longer cycle that stretches around 5 years. These cycles were recorded as far back as 1836 by Sir John Herschel and probably even earlier in local oral traditions. What makes this star cryptic isn't just its changing splendor, but its capriciousness. Unlike many stars that follow unsurprising patterns, it irregularly digresses from its cadence, diminishing and lighting up, illustrating capricious and less understood processes happening inside its construction. Ongoing discoveries have caught the attention of cosmologists and stargazers worldwide, with an overwhelming and captivating change in its appearance. An event known as the extraordinary diminishing happened in late 2019 when the red very giant, one of the most prominent stars in the night sky, began to mysteriously diminish. The star's diminishing was so pronounced that it started losing its sparkle at a critical rate, reaching its most minimal splendor in February 2020, regularly visible to the unaided eye, even in light-polluted areas. The star turned out to be noticeably fainter, a change observable even to amateur eyewitnesses. However, there is one test with attempting to figure out the events of this star. The time oddity. When we notice a star like this, we are not seeing it as it exists in the present, but as it was in the past, due to the time it takes for light to travel to us. In this star's case, at around 725 light-years away, the light we see today left the star almost 7 centuries ago. This delay makes it challenging to predict and explain sudden changes in a star's behavior, as we are essentially looking into its past. The extraordinary darkening event served as a demonstration of the intrinsic challenges of cosmic perceptions and the limitations of our insight when managing vast, inestimable scales and the time peculiarities they present. This was keenly observed by Andrea Dupree, director of the Center for Astrophysics at Harvard and Smithsonian, and her group. They used Hubble to examine the star as part of a 3-year study to look at variations in its outer atmosphere. These observations provided outstanding insights into the dynamics of a variable star like this one, which routinely expands and contracts, causing changes in brightness. Hubble's aversion to light permitted the scientists to inspect the layers above the star's surface, which were heated primarily by the star's wild convection cells. Further investigation of the Hubble spectra taken at specific points during 2019 and 2020 revealed the development of material in the star's outer atmosphere, especially the spectra focused on magnesium lines, which are typical for heavenly conditions. These perceptions showed material moving at paces of around 200,000 miles per hour from the star's surface into its external environment. This hot, thick material at last expanded a great many miles from the star and formed a cloud that caused the star's darkening. Dupree and her group assessed that twice the typical measure of material from the star's southern hemisphere was lost over the 3 months of the eruption. This mass loss was significant, particularly since, like all stars, this one consistently loses mass, but at a much higher rate than our Sun. The size of this mass launch and the subsequent diminishing sparked conversations among cosmologists about whether this event could be a precursor to a gigantic blast. The vicinity of the star, around 725 light-years from Earth, adds to the interest, as such a blast would be visible from Earth and provide a unique opportunity to witness a vast event up close. However, this has yet to be fully addressed. What does this darkening event mean for the star's future? Is it an indication of a looming supernova, or is it simply an exceptional episode in the star's long and complex life? Several hypotheses have been proposed to make sense of this surprising change. One prominent hypothesis proposed a stage in the supernova process, a theory that gained momentum due to the widespread belief that the star is approaching the end of its life. Another critical hypothesis involved dust, perhaps from the star itself. Like other red supergiants, it is believed to shed material, and it was thought that this material could form a dust cloud thick enough to block the star's light from our perspective. A third explanation considered changes in the star's photosphere, the visible outer layer, which could affect its apparent brightness. Further investigation using different observational methods uncovered this mystery. Spectroscopic tests showed a drop in the star's effective temperature, suggesting that the dimming could be due to a weak spot on the star's surface. This hypothesis was supported by observations that the star's temperature decreased by around 170 Kelvin at the time of the dimming, highlighting tremendous changes on its surface. Ultimately, the key to understanding this grandiose phenomenon came from Hubble's observations, which revealed that the dimming of the star was likely caused by a massive release of hot material into space. This material formed a dust cloud that darkened part of the star's surface, significantly reducing the amount of light reaching us. The dust cloud was said to have originated from particularly hot plasma shot out from a massive convection cell on the star's surface. As it traveled through the star's hot atmosphere to the cooler outer layers, it cooled and formed dust grains, creating a cloud that blocked light from about a fourth of the star's surface. Hubble's bright spectroscopic observations, which began in January 2019, were critical in identifying the sequence of events leading to the star's darkening. These observations provided evidence of gouges of heated material traveling through the star's atmosphere in the months preceding the darkening. In December 2019, several ground-based telescopes also noticed the star diminishing in brilliance, especially in its southern hemisphere. This material, initially more significant than the star's usual emissions, eventually caused the development of a foreboding shadow as it moved outward and cooled. The speculation was that this shot-out material and the resulting shadow caused the star's sudden dimming. The size of the discharge is indeed rare, putting the star into the spotlight. The star expelled an estimated 100 times the mass typically ejected in a normal stellar eruption. This mass discharge, noted to be several times the mass of our Moon, was a critical event for the star and for how we interpret stellar mechanics. However, how such an enormous release of material influences the star and supernova theories at large is still unclear. The implications for supernova theories are significant, as current understanding suggests that red supergiants like this star lose mass at a relatively predictable rate before the explosive end of their lives. The unexpected size of the discharge complicates this belief, suggesting a more violent and possibly unpredictable end-of-life stage for these stars. Might the star be nearing the edge of a supernova? The question presents a potential risk within the vast vicinity. While the timing of such an event remains uncertain, the recent mass discharge has certainly shifted the discussion, indicating a more imminent end than previously thought. Theories now wrestle with the implications of such significant mass loss and what it means for the star's survival and future. However, as the infinite cosmos continues to unfold, the ultimate fate of this star remains uncertain. Local area anxiously watches the star. Another huge occasion catches our consideration and offers a nearby gander at a cosmic explosion, SN 2023 ISF. This cosmic explosion happened in the universe known conversationally as the Pinwheel Galaxy, situated around 21 million light-years away. Seen in May 2023, SN 2023 ISF fills in to act as an illustration of the dynamic and ever-changing nature of the universe, where stars carry on with their lives in a fabulous pattern of creation and demolition. As we continue to unwind the secrets of the universe, this star remains an important wellspring of discovery, giving insights into the inward activities of stars and the forces that shape our astronomical scene. The future of the red supergiant. As we dig further into the new events and attributes of this red supergiant, we should think about the potential future situations. The star's huge launch of material and the ensuing diminishing have given significant information that could reshape how we might interpret the last phases of stellar development. Potential cosmic explosion. One of the most charming conceivable outcomes is that this star could be approaching the finish of its life, coming full circle in a stupendous cosmic explosion. A cosmic explosion is a galactic event that happens during the last developmental phases of a huge star's life, marked by one final titanic blast. Such a blast would surpass a whole system for a brief period, delivering gigantic measures of energy and contributing to the improvement of the interstellar medium with heavy elements. The new mass discharge noticed could be a precursor to this devastating event. In the life of a massive star, the cosmic explosion stage follows the weariness of atomic fuel in its center. The core collapses under its own gravity, and if the star is gigantic enough, this breakdown sets off a cosmic explosion. The material catapulted during this event enhances the surrounding space with elements that form new stars and planets. Stellar elements and instability. The noticed anomalies in the star's conduct, for example, the incredible darkening, show huge instability. This instability can be credited to the complex processes happening in the star's interior and its external layers. As the star approaches the finish of its life, its core becomes progressively unstable, leading to convective flows and the launch of material. These convective flows are driven by the intense fusion reactions happening in the star's core. When hydrogen fuel in the center is drained, the star begins fusing heavier elements and shells around the core. This shell burning makes violent convection flows, which can lead to the launch of material. These launches, in turn, form dust clouds that can darken our perspective on the star, causing the noticed darkening. Astrophysical significance. The ongoing investigation of this red supergiant holds critical astrophysical significance. By noticing the changes in this star, cosmologists can gain insights into the last phases of stellar development and the cycles paving the way to a cosmic explosion. It is crucial to understand these cycles for building accurate models of stellar life cycles and predicting the behavior of other massive stars in the universe. Observational procedure. Current observational procedures have been urgent in uncovering the secrets of this star. The James Webb Space Telescope, JWST, and the Hubble Space Telescope have provided high-resolution data that allow cosmologists to study the star's atmosphere, surface temperature, and material discharge in phenomenal detail. Ground-based telescopes have supplemented these observations, offering a broader perspective on the star's instability over time. Implications for stellar models. The data gathered from the observations of this red supergiant are now impacting stellar models. Traditional models of red supergiants and their life cycles are being rethought in light of the new discoveries. The unexpected mass launch and the star's dramatic dimming suggest that these stars might undergo more erratic and turbulent changes than previously thought. Broader impact. The potential cosmic explosion of this star also has broader implications for our understanding of the universe. Supernovae play a crucial role in the cosmic cycle of matter. They are responsible for making and scattering elements heavier than iron, which are essential for the formation of planets and life. By studying the star, we gain a deeper appreciation for the interconnected processes that shape our universe. The red supergiant at the heart of this study continues to fascinate astronomers and the general public alike. Its new behavior has provided an abundance of data that challenges existing theories and opens new avenues for research. Whether this star will end its life in a spectacular cosmic explosion remains to be seen, but its story is far from over. As we look ahead, continued observations and advancements in technology will undoubtedly reveal more about this mysterious star and its place in the astronomical tapestry. For now, we can only watch and wait, hoping to witness one of the universe's most dramatic and remarkable events, the death of a star and the birth of a new era in our understanding of the universe.